I would like to give the physical intuition behind what do you mean by the T shifting. So when you are working with the signals and systems, okay, especially with the function generator or the arbitrary wave generator, the wave generator or the function generator will start generating the function like sine function or a square wave, etc. And when you are going to start the pulse, there is a timer. We are going to start the timer, and then from that time onwards the sine wave will be generated. So that means essentially if you are going to represent it in a graph, for example, let us draw a graph like this. So at a particular time the generator is going to generate the wave, and then you can give this to the CRO, and then you can see this particular wave. This is fine. Now the question is, what we are asking is, rather than starting the signal at t equal to 0, timer t equal to 0, I want to make, let us say I want to delay it by, this is 1.54, right? Pi by 2 is 1.54. So I want to delay the signal by 1.54 seconds. So when the timer ticks 1.54 second, the signal generator will start another wave. If that is the situation, how will you draw the graph? So if that is the situation, you can now see we are going to start the wave only from or only at the time t equal to pi by 2, t equal to 1.54 second. If you are going to start the sine wave, I am going to start the sine wave only. So this graph is also sine wave, but now I will say that this is sine of t minus pi by 2. So that is the graph I am planning to draw, which means that this will start only from pi by 2. So it will be going like this, comes like that. So what you understand from these two graphs is that this graph is shifted. Simply you copy this graph, shift it, and then paste it. That's all you do in this particular case. But in experiment you will be doing like this. At time t equal to some particular time, you can start generating the graph. So this is what happens in experiment. But now we want to do this same thing in mathematics, namely in Laplace transformation. So which means that I need an equation for this particular graph. This graph, I need an equation for that. Then you may say that, oh, there is already an equation is there here. So this is the y-axis, right? So this is y equal to sine. This is y-axis is there, the t is there. So sine of t minus 2 is already there, right? So that is the equation, right? That is what you say. But if you say that this itself is the mathematical equation representing this wave, then you will be making a mistake, because mathematically speaking, the mathematics will plot this particular portion also. Because you can continue this like a wave here. So if you are going to continue like that, that will be the portion of wave which is like this. It will continue and then come here. So this portion, which is dotted portion, so dotted portion of the wave will be generated by mathematics. This dotted portion will be generated by mathematics, whereas your apparatus or the function generator will generate the wave only from this one. The dotted portion, nothing will be there. So nothing will be there means zero signal will be there. Zero signal will be there in experiment, whereas the dotted signal will be there in mathematics. So therefore you cannot compare mathematics or we say theoretical work with the experimental work. So now you understand the problem. When we want to do the similar situation corresponding to an experiment, the dotted portion of this graph has to be made to 0. Why do you want to make 0 is the signal generator will keep quiet. It will not emit or it will not generate any signal from 0 to 1.54 second. That means nothing is emitted or nothing is generated. It's not emitting. So let us say it is generating. When the signal is not generated, there is actually 0 volt is there. So once after that it generates according to this particular shape. So we have to remove this dotted signal in the mathematical equation. This is the mathematical equation. So how do you do that? So the idea is like this. The original function that we have, time shifted function, is t minus pi by 2. That's what you have, this expression. So what you do is, it's very simple. You simply multiply this by 0. Mathematically, right? Mathematically you can multiply by 0. So from the time 0 to from the time 1.54 second, during that time you multiply by 0. And once the time starts from 1.54 second, you multiply by 1. Same expression. So we have the sine of t minus pi by 2. So this is your function that we have. This is the function. Only thing is I am multiplying by 0 in one case, I am multiplying by 1 by another case. When I multiply by 1, the same function remains. When I multiply by 0, this dotted portion becomes 0. So that's the meaning. So which means that you can actually remove this dotted portion. This dotted portion can be removed provided you multiply this by either 0 or 1. So the question is that you have to write down either 0 or 1. So how do you write either 0 or 1? For that you introduce a function called the unit step function. So that's what I'm going to write down, that this is h of t minus pi by 2. So basically h of t minus pi by 2 is not a complicated thing. It is nothing but h of t minus pi by 2 is nothing but it is either 0 or 1. So in a simple language, I will write down what is this. It's all the same. Let me write down here h of t minus pi by 2. This value will be equal to 1 if t greater than or equal to pi by 2. 0 otherwise. So now you understand that this is either it is 1 or it is 0 depending upon whether we are staying this side or to the left of this side. So now everything is now mathematical. Now this is a piecewise continuous function, completely mathematics, and the sine of t minus 2 is another mathematical equation. You can always multiply and then your computer can generate the values. I don't require a signal generator. Right. So therefore what happens is, in this way you can do the calculation, and this particular function is called the unit step function, and let me therefore write down the name for this. So you can say this is a unit step function. We say US unit step function, okay, or Heaviside unit step function. So USF is the most frequently used name, unit step function. You understand that unit step function means either 1 or 0 depending upon whether we are staying greater than some number or less than some number. So now the point is now clear from this expression. There is nothing special about pi by 2. Okay, we don't have to do it only at pi by 2. Any time you can do the shifting. So at any time you can actually shift this graph. Therefore we do not say that it has to be only at pi by 2. So it could be any number. So therefore we will say that this is something like t minus a. A could be anything. So if that is the situation, we can now write down that this is a here. So this is the definition for this. H of t minus a is called the Heaviside unit step function, but little bit confusion will come when you refer to multiple books because there are also other symbols used there. So here I would like to write down that h of t minus a is also written in some books as u of t minus a because it is unit step function. In some books they also write like that. In some other books they also write like ua of t. That means it's actually u of t. How much it is shifted, that is there as a suffix here. So all information is there. Why should I write t minus a? You say that shifting amount is written as suffix here. Anyway, it's a function of time. So I am writing ua of t. So these are the three possible symbols that you can find in various textbooks. So therefore one should not get confused. So you should be familiar. All these things are nothing but just 1 or 0. That's all about it, and you can multiply. So this is the whole idea about the t shifting, because this axis is t axis, and in experimental situation this is time. So okay, so now you understand what is the need for this, and the important point is that this function is multiplied by this function. So I would like to write down what is this function. Sign is not important for us, it can be any function. Therefore we say that it is any function which is shifted by any amount. F is any function, t is there. Rather than pi by 2 we can shift it by any amount. Then you have a multiplication by the Heaviside unit step function, which is nothing but t minus this same a has to come here. That is very important. The same a has to come here. Only then you can shift by exact amount. So this product that we are going to get, this is the actual shifted signal. This is a shifted signal. So you understand this idea about the t shifting. This is good. I have the function here which is a shifted signal. The question is that how are you going to take the Laplace transform of this shifted signal? Laplace transform of the shifted signal is how much? So Laplace transform of, so that's all about it. So this is how much? Okay, so the idea is clear. We will do this. This calculation is very easy. We will do how to proceed with this integration. We have to perform an integration based on the definition of the Laplace transformation that we will do in the next class.